Hello, everyone. We'll be discussing a summary of about polynomials. That is so that you can perform. Let's start with the basic definition of polynomials. So, firstly, what is a polynomial? Polynomial is basically
Okay.
where you have
Hello, ma'am.
yes,
I guess your voice is
Okay.
low.
Just now I started the stream. Yeah, okay. Okay, thank you, Preston. Thank you, Hiba, for sharing. Okay, I'll share the screen, guys.
Yes, ma'am.
Is it 2?
Zero.
Zero, ma'am.
Zero.
No, one, ma'am.
No, it's 0. This also starts from 0. So the indexing of this list also starts from 0 and 1. So this is 4th element, and this is going to be 0. So it's 4 and 0. Okay. Is this clear? Whoever said it was 2 or 1?
Ma'am, please tell me again.
Ma'am, I thought actually you asked for orange, ma'am. So that is the reason I said.
Okay. No issues. So in
मैम आपकी आवाज नहीं आ रही है
that's because I wasn't talking. So, just 1 second. It's,
Ma'am, your voice is not audible.
is it better now? Am I audible now?
Yes, ma'am. You are audible, but it is low actually.
Okay. So, let's get started with the session, and if it remains a little low and not audible, then I'll try something and try to fix it. Is that okay?
Okay, ma'am.
Yeah.
Your voice is
So,
very feeble, ma'am.
Ma'am, your voice is not audible.
I'm not even saying anything. Just, is it okay? Let's get started with this thing. Is it better now? Or then, if the voice issue and the audio issue exists, it still
Yes, ma'am. It is
continues, then we
clear.
No,
can.
ma'am, now it's audible. Yes.
So let's
It is
start
audible.
with the okay. Let's start with the basic definition of polynomials. Or the definition, it says there's obviously a general form for polynomials, but in polynomials, what you do is this is the form where you write a naught plus where all of the ai's that I'll write. Let me just first write the expression a2x square plus it continues like this and goes till a and x to the power n. Where there are some things to keep in mind. First is your a naught, a1, a2, and all of these an. These ones, the coefficients, these are arbitrary constants, arbitrary for now because we're defining polynomials. Because when you write polynomials, they become fixed, right? So these are, in simple words, these are constant and your x varies here. X is the variable here. And your n, it belongs to a natural number and it's fixed, right? So your n and constants are fixed. The only thing variable here is x. X is the variable here. Everything else is fixed. So these are called polynomials, where you can have, okay, let's just have n equals to, for example, let's say you have n equals to 5. And then you'll have a0, a1, a2, a3, and a5. This will be the constant that will be there. And because the n is 5, so we only have to take till a5, right? So let's take a0 equals to, let's take all of them 1. Let's take all of these equal to 1. Or let's take these ones 1 and the other ones 2. This thing becomes, this expression then becomes a0 is 1, so you'll have 1 here. Then a1 is also 1, so we'll have x here. Then x squared. Then a3, a4, a5 are 2, so you'll have 2x cubed, 2x to the power 4 and 2x to the power 5. Now, obviously, these a0s, these ai's could be anything. They could be 0 as well. In this expression, you don't have any 0 term, but you can have 0, right? You could have chosen the coefficient of x to be 0. Then you wouldn't see x here. This is also a polynomial, right? So these are called polynomials. What's allowed when you are looking for polynomials? First thing that you need to see is the rules to it, obviously, where you can multiply with. Okay, let's just talk about terms first. Terms are these. This is a term, this is a term, this is a term, right? These individual things are called terms. So for terms, you have multiplication with a scalar, or you can simply say with a real number is allowed. We're taking real because we're taking the coefficients to be real. In our entire course, we'll only be dealing with real numbers. That's why we're taking it to be real. That's allowed. Then natural powers are allowed. Natural power means your power should be, this is the power, right? It's also called the exponent. This should be power should be natural number. Which includes 0, obviously. So you can have that as well. You can't have negative numbers here. That means in the power, you shouldn't be having negative numbers. And we have written it here, right? These things, all of these are natural numbers. You cannot have fractions or negative numbers or irrational numbers. You can't have all of these here. So the power should be a natural number. It can't be a fraction, then can't be a negative integer. There are a lot of things. Basically, other than natural numbers, you can't have anything else here. So that's the other thing. And then you're allowed to add terms. This was about terms. So in a term, you're allowed to take the powers, the natural powers of your variable, and you're allowed to add terms, right? Add them and subtract them. You can have negative sign here as well. When I write negative here, obviously your a0, a1, a2, an, and they're coming from real numbers, right? All of these are from real numbers. That means your a1 can be negative. That would mean that you can subtract terms as well, right? For example, you can have a negative sign here, you can have negative signs here, but you can't have a negative exponent. Multiplication of terms, multiplication, addition, and subtraction, all of it is allowed while constructing a polynomial. This is what you can do while constructing a polynomial. Then let's discuss this. Now, if you have a polynomial, let's try to look at a polynomial as a function. So your polynomials are of this form, right? A0 plus a1x plus so on till an x to the power n. This is a polynomial which we represent as, because your x is a variable here. So can I say that this entire thing is a function of x? For this
Yes,
to be a
ma'am.
function of x, what's the condition for a relation to be a function? What are the two conditions?
Ma'am,
You should pass
every
vertical line test.
This is a relation from R to R, right? If I put a real number in this expression, let's take a simplified version. The polynomials are definitely a relation from R to R. That means you can take values from R and you will get values from R only, right? So let's say you have 3x squared plus x plus 1. Let's consider this in particular. Then what are the two conditions that it does satisfy? That every polynomial which is of the form a0 plus a1x plus so on. What are the two things that it should satisfy for this thing to be a function? So first is if you're taking it from R to R, right? This is from R to R. Then you should be able to put this thing, every number from R in this, right? That means this should be a valid expression for all R, which is true, right? Is there any real number that you can't substitute there? Please mute yourself. Is there a doubt? Okay. So if you have this thing, the first condition is, why is it a function? Your first condition for a function should be it already is a relation, and the relation is a function. For that, for a relation to be a function, first condition is it should be well defined for every element in the domain, right? So you do know what we mean by well defined, right? Does everyone know the meaning of well defined?
yes, ma'am.
Others?
Yes, ma'am.
Yes, ma'am.
So it should be well defined. Well defined means this expression should make sense for every real number, which it does. An example for an expression that doesn't make sense for all real numbers is this. If you take x minus 1 by x minus 2, then this expression does not make sense for x equals to 2, right? That's why we say that this function is not defined for x equals to 2. That does not happen here in this case, or for that matter, for any polynomial, every polynomial is defined for every real number, right? So we have taken a particular case of polynomials to make things simple. And then the second is that if you have, this is your domain, this is your codomain, then this should not happen, right? That means if you have one point, that point should not have two images, right? So do we have a point here which would give you two images?
No, ma'am.
That means if you put a particular value here, try to put any value here. Can you get two values from, if you substitute a here, you'll have 3a square plus a plus 1. Can this have two values? This is going to take only one value, right?
Yes, ma'am.
Like what happens when you take plus minus square root of, if you take this thing, now this can have two values, right? If you take this relation, then if you take 9 here, you will have plus minus 3. So it can have, now you're substituting x, you have 9 here, and 9 have two values here, two images, plus 3 and minus 3. That's the problem, right? That's not happening here. Doesn't happen with polynomials because all of the powers are actually natural numbers. That can never happen here. So unique image for every element. That's why your polynomials are functions. And they're functions from, so we will be denoting polynomials with px everywhere. So your px is actually a function which is defined with variable r. So the variable here is like we used to write fx, where the variable was x, and f was called a function of x. In a similar way, a polynomial is a function. A polynomial p is a function of x, which is defined from r, and its codomain is also r, right? Then let's come to the type of polynomials. So the first type is in one, let's say you have polynomials. So it has different classifications. One is based on the type of polynomials based on number of variables. So one is when you have only one variable, like this one. So when you only have one variable, your expression looks like this: a naught plus a1x plus so on, an to the power an x to the power n, right? Where your n is, it could be anything, right? 5, 4, 10, 20, 100, it could be anything. That's in one variable. Then you have polynomials in two variables as well. Those are not in the syllabus, but let's still see what they look like. They look like this thing, where you have, if you try to write the general expression for it, it will be like this: a naught x to the power, okay, x, then b naught, or let's just take this one. First is a naught, then a naught x plus b naught y plus c naught xy, and then you take, so it's basically, because if you write it in expanded form, it will be very complicated. So what you can do instead is you can write it in compact form, where this can be written as ai x to the power I, where I varies from 1 to what? This is, are you guys familiar with this symbol, summation 1? Summation means the sum of this. For example,
Yes,
let's
sir.
say you have,
I should be started from 0, right?
right, it's from here, we know. So your summation symbol means if you have summation ai, I varying from 1 to n, let's say, this means you have to take sum of, this just means a1 plus a2 plus a3 plus so on till an. This is what summation means, from I varying from 1 to n. So here you can write this in compact form as this, right? I starts from 0. This gives you a naught x to the power 0, which is just 1. X to the power 0 is 1. So any variable raised to the power 0 is 1. This is another thing to keep in mind. Then you'll have a1 x to the power 1, a2 x to the power 2 in sum. And this will end at n. It starts from 0, ends at 0 and n. So if you were to write this thing, you write it as summation ai j x to the power I, y to the power j, and actually you should take double summation here, where I varies from 0 to n and j varies from 0 to, let's say, m. So what does this mean? This basically means, I know this expression looks very confusing, especially it has two summation symbols here. It just simply means that you have, if you were to write it in simplified form, it will mean a not 0, 0, then you will have x to the power 0, y to the power 0, plus a not 1, x to the power 0, y to the power 1, plus so on, a not, the j is still m, right? So you will have m here, x to the power 0, and y to the power n, right? This means we're expanding this expression. And then because you're done with the 0, 1, so you can change 0, you can have 1 this time. 1, 0, x to the power 1, y to the power 0, plus a 1, 1, x to the power 1, y to the power 1. So you can have expressions like this. That means in this entire thing, it will obviously stop here. Where will it stop? It will stop at a n m x to the power n and y to the power n. It will stop here. So that means you can have coefficients as is. You can have coefficients as anything. The terms initially here in one variable, you used to have only x here, right? X and then powers of x. And not powers, actually just natural powers of x. That's the same thing you do here. You take the powers of x, take the powers of y. So what is allowed here? You can have the terms like this: x square plus x cube plus y cube plus x square y plus x to the power 10, y to the power 20. This is allowed in polynomials in two variables. Is this okay? Only thing you need to keep in mind is that the powers should not be negative. That's it. The powers should be just natural numbers. The power of x, power of y should be a natural number. Is that okay? So
Okay.
these are called variable in polynomials in two variables. Then you have polynomial in more than two variables, where it's even more complicated. So you have stuff like this. More than two variables. Can someone give an example of a polynomial in more than two variables? 3 variables, 4 variables, anything?
XYZ can be a simple example.
X, Y, Z, you can have x square, y square, x square, y, z cube, z to the power 4. You can keep adding things just to keep in mind that the powers should be natural. That's it. Here the power is 1, 1 and 1. You can have a constant 2, 20, where the power of x is 0, y is also 0, z is also 0, right? These are the classification of polynomials based on number of variables. Then you have classification based on degree of polynomial. Let's first discuss what's degree of polynomial. So in degree of polynomial, let's say you have a polynomial px, and we'll only stick to the ones with one variable. We'll not go to the two variables or more than two variables. So if your polynomial looks like this, a0 plus a1x plus a to the power k, x to the power k. Then the degree of this, degree of px, is the highest power that a term has. So the highest power is k here because it's an increasing order, right? Power 0, power 1, power 2, and so on, power k. This will become k. Now, let's take an example that will make things better clear. It's the highest degree. So if you have 3x cubed plus 5x to the power 7 plus 4x plus 1, then the highest degree is, it doesn't mean that you have to check the last one or the first one, whatever. Because then the degree of this becomes, let's say this is your polynomial, and degree of px is 7. So the highest power, basically. This is for one variable. If you have to discuss degrees for higher variables, for more than one variable, those type of polynomials, that's not in the syllabus. But if you have to discuss degree of x square y plus xy square plus xyz, then the degree is basically the highest degree of the term. So the degree of this term is, let's do it one by one.
3.
Yeah, right. The degree of x square y is basically the degree of x, which is 2, the degree of y, which is 1, and you take the sum of this, so you get 3. Similarly, degree of xy square is 3, and degree of, let's take 2 here. Degree of x, y, z square then becomes 1 degree here, 1 degree here, and 2 here, so it should be 4. You just have to add powers, 2, 1, and 1, so you get 4 here. So this is the degree for each term here. And you have to, for the degree of this entire polynomial, you have to pick the degree, the highest degree out of these. So the degree of this is 4, this is 3, this is 3. So you should pick 4 here. That's the degree of entire polynomial. We do the same thing here too. The degree of this term is 3, degree of this term is 7, this one is 1, and this one is 0, right? Also, degree of constants is considered 0, because if you have a constant, let's say you have 3, the polynomial is, this is also a polynomial, right? If I have just 3, this is a polynomial, right? Because I can write it as 3 x to the power 0. That means this is a polynomial. If you'll compare this thing to a0 plus a1 x square x plus so on an x to the power n, then what's your n here? Right, 0. And what's your a0?
A0 is equal to 3.
This is also a polynomial, and the degree, this is called constant polynomial.
Ma'am, here this constant term has to be non-zero, right?
Yeah.
Okay.
This is a constant polynomial. And the degree of this is, because you can write this as 0, so the degree should be, or degree of 3 should be 0, right? Because it can be written as 3x to the power 0, and there are no other terms with bigger power, right? That means the degree of 3 is just 0. But one important thing to note here is that that means, this implies degree of px equals to constant. So this is constant, is equals to 0. But only when your c is not equals to 0. That means if you will take non-zero constant term, if you will take 4, then the degree of 4 is 0. But if you will take 0, then degree of 0, 0 is also a constant, but this degree is not defined.
No.
And why do we have a problem with 0? Does anyone want to guess why we have a problem with 0 in
Ma'am, because we can expand it
You can multiply
with
with any other variables, right, ma'am? And still the
yes,
answer will be
ma'am.
0.
Just like 0 into x to the power 1 plus 0 into x to the power 2.
If you have 0, you can write it as 0. If you are thinking that we can write this as 0x to the power 0, then you can continue this as 0x to the power 1, 0x to the power 2, and this won't be fair, right? You're considering this term, and if you delete others, that's unfair to other terms. So to avoid that thing, we don't consider, we consider this degree, we don't define it at all. We say that this, when we don't talk about the degree of 0. Not defined simply means we don't talk about the degree of it. That's when you have a 0 polynomial, we consider the degree to be not defined.
When we have multiple variables, still we look for the biggest degree.
Yeah, you look for the biggest in the terms. Let's say you have 4 variables, x, y, z, and t. Let's say you have these 4 variables, and you have to write a polynomial in, be denoted by this polynomial in x, y, z, and t. have this thing, you'll have, let's say you have x square plus yzt plus zt square plus t cube z square. Then you have to see the degree of individual term. The degree of this is 2. This one is 3. This one is 3. And this one is 5. And then the maximum out of all of these is 5. That means the degree of p, x, y, z, this one should be 5. Is that okay?
Ma'am, is not the degree of 4 1? I think I don't know, on the left top corner.
Yeah, this is a mistake.
Yeah.
In the above, you written
No,
degree.
the degree is, wait, the degree
Degree
of
is
4 is
0
0.
only.
It's 0.
0, right, ma'am?
What's wrong with this? Yeah, this is 0.
Can you scroll
How,
above?
can you explain that, ma'am? Degree of 4 is.
Yeah.
The degree of every constant, maybe I forgot to mention it explicitly here. So I write it as a point here. Degree of a constant where c is a constant, actually non-zero constant, is 0. And degree of 0 is not defined. Why? 0 we already discussed why it's not defined. And we're talking about the degree of constant term. So for constant term, this one, you can write c as a polynomial where this is c x to the power 0 plus, now you don't have to take others, right? Because the others are 0, so we don't take them. So this will be, and now you compare with, you have to find the highest degree, right? So the highest is 0 only because there's nothing else.
Yes, ma'am. Just got
The
it.
same logic doesn't work with 0 because if you start writing it as 0 x to the power 0, 0, then you can also write this thing, then this thing. That's why this logic fails here. That's why we consider this degree to be not defined. And the degree for this one is 0. Does anyone have any other doubts so far?
No, ma'am.
Ma'am, actually, I had a doubt.
Yes.
Actually, I'm getting confused about the exponents and negative thing and whether they're polynomials or not.
Okay. Let's take examples of what are not considered polynomials. Examples of non-functions or relations that are not polynomials, or functions that are not polynomials. So your first example would be, let's take x to the power half. Now, if you have this thing, then what do we want? We want to be able to write, if this is a polynomial, then we should be able to write it as a0 plus a1x plus a2x square and so on till an to the power x to the power n, right? Even if we start with it, we can take a0 to be 0, a1 to be 0 because there is no term with x, right? Here we don't have any term with x, no term with constant, no term with x square, no term with x to the power n. That means we can take all of these to be 0. That's fine. But the problem is that here we don't see any half. The only powers that we have for x here are x to the power 0, x to the power 1, x to the power 2. We are continuing in this manner, right? And x to the power n. That means this is not allowed here. So an
Okay.
exponent shouldn't be, this should not be a polynomial. That's not a polynomial because you can't simply because you can't write it in this manner, in this format. That's the reason why it's not a polynomial. And second example
Okay.
could be x to the power minus 2. Now again, if you try to write it in this format, you can't write it because the only terms that we have x to the power 0, x to the power 1, x to the power 2. So you're only allowed to take natural powers of your variable, right? So if x is your variable, then the powers of x should only be natural numbers. And this is not a natural number. That's why this isn't allowed either. This is not allowed. Then if you have anything else, let's say you're taking this x to the power 1.9 plus x square. This is also not a polynomial. Or if you take x to the power square root of 2, x to the power e, that's also not a polynomial. All of these are not polynomials, right? E is your, I don't think you guys, a lot of you are familiar with this. This is 1.7. This is a constant that we use that a lot. This is called E. It's an irrational number, keeps continuing. It doesn't stop anywhere. So all of these are, if you have any particular example and you want to check if that's a polynomial or not, we can check that too. Sometimes it looks like it's not a polynomial, but when you reduce it, it becomes a polynomial. Like if you take square root of x minus 1 and then square root of x
Ma'am,
plus 1. Yes.
do we consider 1 upon root 2 to be a polynomial?
1 upon this.
Yeah, is it considered a polynomial term?
Okay, it depends on if, because we take our coefficients from real numbers, right?
Yeah,
We consider the polynomial to be a function from R to R. And we're only
okay.
interested in if you will take this thing, then this is clearly not a function from R to R. That's why it's not a polynomial
Ma'am, it
with
is a
coefficients in real.
function actually. Root 1 by root 2 is a real number. It is irrational, but it is real.
Yeah, yeah. So
It is a function,
yeah, that's a real number.
not a.
This is a real number, so that means, yeah, then it should be a polynomial, right? It's a polynomial in real numbers.
So why not 1 upon under root of x? I mean, x can be replaced with any other constant term. So just because we are not able to write in that form, we don't consider it as polynomial, right?
What 1 by root x you're talking about, right?
Yeah, if x is replaced by any constant, then it becomes a polynomial term.
Then the
Okay.
domain is restricted to positive real number here. So that is why it is not polynomial, I guess.
Okay, what the definition, whenever you have to check if something is a polynomial or not, I'd suggest you to use this thing and compare the expression with this, because this is the easiest way to check. And how do you check it? Now, there are two factors to it. One are the coefficients, obviously, these ones. They don't have anything as restriction in particular, except for the fact that you need them to be real. Like 1 by root 2, that's a real number, so that's fine. 1 by root 2x is also fine. But you're saying if you replace it with if you replace x with 2, that's a different thing, right? If you replace this x with 2, then this thing, which is a polynomial in x, right? You have, okay, this polynomial, and if you do this, a0 plus 2a1 plus 4a2, if you replace x with power n, this polynomial, and these are two different things, right? Now this becomes a constant polynomial. They're not the same thing. I don't know why you're getting these things confused. You just have to see that your x should not have 2 having power half, or for that matter, 2 to the power minus 10. That's fine. So the constants having any power, as long as this number is a real number, is fine, which is always true. Taking powers of a real number results in a real number. That's fine. But it becomes a problem when you start taking powers of x as numbers that are not natural numbers. This is a problem because this is simply x to the power minus half. And minus half is not a natural number. That's why it's a problem.
Okay.
Now, what's the confusion in this? Is there anything particular?
Ma'am, basically we seeing a variable and that's power. When power is natural number, that's a polynomial, and
Yeah.
yeah.
So you only have to check for, yes.
You were discussing about some function that is root under x plus 1 into root under x minus 1. Can you discuss about that?
Yeah, if you have something like this was a very simple example where if you look at this thing, then this results in x minus 1. Right? This is a polynomial, but at first glance, because you see a square root here, it doesn't look like one. Or the things could be even more complicated. This one is a very simple one, where it's clearly visible that this can be simplified to this. and this hence should be a polynomial. But there are other cases where if you were given something like this, or if you're given this thing, so this isn't a polynomial, right?
Okay, ma'am.
So you
Ma'am,
will first need to simplify things. Yes.
ma'am, I'm saying that for every polynomial, is it fixed that it is defined from R to R?
In our course, we're defining it from R to R.
Okay. Okay, ma'am. If that is R to R, then this expression is not polynomial, right? This x minus 1.
No, this, which one?
Ma'am, this one only, root under x
This
minus
one.
1. Yes, ma'am.
No, why is it?
The
This is a
left one, ma'am.
polynomial.
The left
They're
one.
both the same. These two things are same, written in different ways.
Okay, okay.
They're both. That's why I said this. This doesn't look like a polynomial,
Then,
but it's this only.
okay, ma'am.
You'll have to
So,
simplify it. Yes.
but in the left expression, here the domain is R plus. Is that? It is not R.
Yeah, it's not R, but it's
R plus. So, is that the reason? Can you consider it as a not polynomial?
I mean, I don't think so. Because if you just,
Because every polynomial, the domain is R, right?
it is R.
Here the domain is R plus, right, ma'am?
Okay, but these expressions don't vary, but they vary as functions. Because if you have this as function, root x minus 1 and root x plus 1. Now, this as a function is different from x minus 1 as a function.
Yes,
Because
exactly.
the domains are different. But
Yes.
they as expressions, these both are same.
Okay, ma'am.
Ma'am,
Ma'am, the
we can
degree.
rearrange the equation for polynomial.
What?
Ma'am, we can rearrange the equation for polynomial.
Which equation are you talking about?
Like x to the power 1 by 2 is equal to y.
Okay, if you have y is equals to x to the power 1 by 2, then what are you going to rearrange here?
Suppose, ma'am, both side we are squaring now, so that's is polynomial.
If you square on both sides, then
Okay.
see what happens is
So
you
this
can
is
write this
polynomial.
thing as function of y,
And
and these two are different things. One second.
yeah, ma'am, first equation is also polynomial.
No, these are not. It depends on what you're talking about, and this is when you talk about polynomials, you don't.
Okay.
There should be no equals to sign because your polynomials look like this, right? Do you see any equal to sign here?
Okay.
It should just be an expression like this. So you should not have y equals to x equals to. I think you're getting confused in this thing. We write this as y because this is a function, right?
Okay.
So we can
Thank you,
write this thing as. Is it clear?
Yeah. Thank you, ma'am.
This is a function. Okay. I'll still
Why
explain
is
it.
the codomain?
It is what?
And why is the actual range of the function?
Okay, we'll come to the range of polynomials. Let's first discuss this thing. If you have this thing, firstly, a polynomial is just this expression. This is called a polynomial. So if you're talking about this thing, if this is a polynomial or not, then you should, I'm assuming you're talking about this. Because you have two things in variable form. One is this, the other one is this. Now this is a polynomial in y. This is not a polynomial. Similarly, if you have this thing here, then both of these are polynomials. This is a polynomial in y. This is a polynomial in x. Polynomial in y means your variable is y there. Is that okay to everyone?
Ma'am, y is equal
Yes.
to x to the power 1 by 2. This is equal. So we suppose square in both side. So also it is equal.
So these two are okay.
So first question is not a polynomial, but the second question is second equation is also polynomial. That's
You're not getting the point. My point is you're confusing it with functions and all. Your polynomials are definitely functions in x, but your polynomial is just in this form. You should not have an equal to sign there. Why is it there? If you have y is equals to x to the power half, then you have two expressions in variables. One is this one,
okay,
x to
okay,
the
ma'am.
power half.
When first of all we converted this type of equation like a naught plus a1, and then we compare like
You
polynomials.
why what is this thing doing here? Equals to sign
Yeah,
should not be there while discussing just polynomials, right? So you have, if you have this expression, then you have actually a polynomial here, which is this. This is a polynomial in y. Polynomial in y means your variable in this polynomial is y. Like here, your variable is x. In this polynomial, a variable is y. Now, this other expression is not a polynomial. A polynomial is just an expression which looks like this.
thank you,
And you're
ma'am. Yeah.
talking about the other thing that you were talking about was y square equals to x. Now, this is again, there are two expressions here. One is this one, the other one is this one. This is a polynomial in x. This is also a polynomial in y. And these two things are not the same. Y is equals to square root of x is actually a function. Y square is equals to x is not a function. There are a lot of differences. The graph of this looks like this. It looks like this. It's y square is equals to x looks like this. And the graph of y is equals to root x looks like this.
Yeah, yeah. Yes, ma'am.
So these two are different things. They're very different. They're not same. Okay. Then we move to the next thing. If this is clear to everyone.
Ma'am, actually, I had a doubt from weekly activity question.
We'll have two more classes. One of them is a doubt session. The other one is solved with us. You can ask those doubts there.
Ma'am, in the rules of terms, you have not mentioned the a division.
Division, okay, if you're going to divide things, they should be completely divisible then. Like we were saying that if you have x cubed and if you have x squared, and if you multiply these two things, that's what I meant there. This will be x to the power 5. So if this is a polynomial, this is a polynomial, you multiply them, it remains a polynomial. But if you have something like this, x cubed, dividing it by x squared, so you get, now here you get x, but if you will have x squared and you will divide it with x cubed, you will get x minus 1. Right? This might not result in a polynomial. It depends on obviously the polynomial that's getting divided and the polynomial that you're dividing by, right? That's why the division is not mentioned there. Is that
Okay,
okay?
so it is for not for the all cases. That's why you have not mentioned.
Yeah, because it generally when you'll divide things, you might not get the resulting thing might not be a polynomial, right? That's why I said you can multiply terms like this, but you can't divide these things and then expect to get a polynomial or a polynomial term. Right?
Okay.
That's why it's not mentioned there.
I
Obviously,
got a question.
polynomials, division, and division algorithm is a thing, and we'll discuss that in this week. That's a thing. That doesn't mean we can't divide polynomials and we can't divide polynomial with another polynomial.
Yeah, okay.
Now let's discuss. Does anyone have anything else? Shall we continue?
We talk about functions later, right? Like we can't talk about any doubt about functions.
What?
I have a doubt about functions, about root x, square root of x.
Okay, root
So,
x.
so
And
if we take
yes.
any natural number, for example, square root of 4, it can be -2 or +2, right?
When you actually when you have to, I think I've discussed this in some other classes. When you write square root of 4, this just means 2. If you want to mention both plus 2 and minus 2, you should be writing plus minus 2. That's why in the quadratic formula too, you must have noticed this thing. You write it as minus b plus minus square root of b square minus 4ac, right?
Yes.
Have you noticed this thing?
Yes.
Because if you will just write square root of b square minus 4ac, this means the positive square root, not the negative one. Is that okay?
Yes.
Yeah.
So my doubt is like, if it gives out, it can give out like two outputs, like one in negative, one in positive.
I
Is it a
can't hear you
function?
very clearly.
Can you hear me, man?
Yeah.
So if it can give us two outputs, then is it a function?
No, it's not a function. If for one input you have two outputs, then it's not a function.
So square root of x is not a function then.
No, that's what we discussed. Square root of x is a function because square root of x means positive root of that number. Square root of 4 means just 2. It does not mean this is not equals to minus 2. This means plus minus 2.
Okay.
That's why this is a function. Now, if you write it as this plus minus square root of x, this is not a function.
And y is equal to x square is also not a
What?
What? Y is equals to what?
It's a function. It's a quadratic function.
Which one?
Y is equal to x square.
Yeah, this is a quadratic function. We've discussed that. That's what we did in last week. Quadratic function. This is a function. Basically, you have a problem in when you get two outputs for the same input. That's a problem for functions. Or you have a problem if you don't get any output for a given input in the domain. So if you take a number from the domain and you don't get any output for that, then that's a problem. Then it's not a function. So for
vertical
every
line test apply here.
Yeah, and graphically, if you look at it, it means if you draw a vertical line and that vertical line could be anywhere. So every vertical line possibly drawn on this xy plane should cut your graph at only one place, at only one point. If it cuts at two or more points, then it's not a function. And if you're saying that this is your domain, if you say that this is your domain, a domain is on the x-axis, right? Because that's what we take the variable to be the independent variable to be x and the dependent one to be y. So your domain should lie on the x-axis. So if this is your domain, then you should have a value. That means your graph should be here. It should not be like this. If this happens, then this is not a function, right? If this thing is your domain, and you see that for this one, for this part, that means for x lying between this here, you don't have an image. That means it's not a function, right? That's also one of the reasons why it won't be a function. Is that okay?
So ma'am, if
Yes.
like for certain graphs, if we limit the domain to certain points, for certain area, like small portion of it can act as a function.
Yeah, it can. So let's say you have 1 by x, right? So now if you look at this, obviously if you just have this thing, then this is not defined for x equals to 0. You have a problem at x equals to 0, right? So this cannot be a function, not a function on R because R contains 0 and this is not defined for x equals to 0. That's why this isn't a function. But if you define it, if this is from R to R and you're defining the function as this is not even a function. If you're defining the relation to be f of x equals to 1 by x, and this is not a function because 0 does not have an image. But if you will restrict this thing to f from r plus 2r, then this is a function, right? Because it's defined everywhere. Or if you will do this thing, f from r to r, and you will define it as fx equals to 1 by x and 0. So for x equals to 0, you're defining your function to be 0. For x not equals to 0, you're defining it to be 1 by x. That's also a function, right? So this is a function. Is this okay?
Yes, ma'am.
Let's move to the classification of polynomials based on degree. So based on degree, classification goes like this. The first one is your constant polynomial, which is just px equals to some constant. Then second is a linear polynomial. What should linear polynomial look like? It's linear, that means you can only have power as 1. Maximum
Yes,
power can
mx
only be
plus
1.
c.
It should be this, right? That's it. That will be a linear polynomial. Then third, you have quadratic polynomial, which will look like px equals a naught plus a1x plus a2x squared. Let's do examples for each. So the example here would be px equals to 2, or you can take 4, or e, or pi. You can take anything, right? And here you can take this to be 2 plus x, or you can take 7x plus 5, px plus 1, these, right? And then here you can have x square plus x plus 1, or x square plus 1, or x square plus x. Now one important thing is a naught should not be equal to 0. Sorry, a1. a1 should not be equal to 0 for a linear polynomial. For a quadratic polynomial, your a2 should not be equal to 0. In a similar manner, you have cubic polynomials. I keep going on like this. We can't discuss all of them. So cubic will be this. A naught plus a1x, a2x square, and a3x. Where your a3 should not be equal to 0. All the others can be 0. This can be 0, this can be 0, this can be 0. Why are we not taking a3 0? Because we're claiming it's a cubic polynomial. That means its degree is 3. This means degree 2 polynomial. This just simply means degree 2 polynomial. This simply means degree 1 polynomial. And this simply means degree 3 polynomial. So if you're taking a polynomial whose degree is 3, then you need to make sure that this coefficient should not be 0, right? Otherwise, the degree will not be 3. So you can take the example as 3x cube plus x square plus just this. This is a cubic polynomial. Why? Because you can write this is the polynomial where it's this x square plus 0x plus 0. Is this okay?
Yes, ma'am.
Yes, ma'am.
Written 0 here, only do it for the terms that have less power than the degree. Don't write it as 0x to the power 4 and all. Because this thing will never stop, right? Don't write these things. You just need the previous ones. This is for your understanding only. Otherwise, this is perfectly a polynomial. You don't even need to write the zero terms here. This is for you to see why it's of the form this. Okay. Then,
Ma'am, hello.
yes.
Yeah. So quadratic, sorry, linear polynomial will always be monomial or binomial. It can't be trinomial. Can it?
Yeah, for it to be a trinomial, it will need. Okay, let's discuss that first, so that
It is
everybody
discussed in the
understands
TE
what
session,
we're
but
talking.
I still have a doubt. That's why.
Okay, let's first discuss what these are binomials and all. So there's another classification of polynomials that is based on the number of terms. So a binomial means, so firstly we have a monomial, which means one term only. So if you're only allowed one term, then it could be a naught, it could be x, a1x, it could be x cube, it could be anything, right? Because you're only allowed one term. You're not allowed more than one term. So this is one term. What are considered two terms? A naught plus a1x is considered two terms. What about a naught x plus a1x square? What do you think of a1x? What do you think about this? Do you think this is monomial?
It is binomial.
It is a monomial actually. We can
What
write it a naught plus a1 into x.
you can write this as a naught plus a1x. That's what we mean by one term. When we say one term, we mean it should only have one power coefficient. So if you have x, you can't have x squared. You can't have x cube. You can't have a constant term. That's considered one term. So everything with x is considered one term. This is considered just one term. So if you have this thing, 3x
But we
square plus
consider constant as a single term also.
1 second, and you have 5x plus 6x square, then these are not four terms, because if these were four terms, then you can further write it as 5x plus 5x. You can keep expanding things, right? There's no end to it. You can make 100 terms then out of these given terms. That's why these should only be, so the same power ones should be clubbed together. So this will give you 9x square plus 15x. So these are just two terms. So this only has two terms. Yeah, what was your doubt?
My doubt is the example you have given. So, for example, it is like x plus some constant. So it is binomial, right?
This is a binomial because these are different. So this is x to the power 1. This is cx to the power 0. These are different because the powers of x are different.
Okay. Okay.
So these will be two terms. But if
But it
you have
is
x plus cx, then this is one term.
okay. Okay. Got it. Got it.
Okay. Then let's come to, now I hope everyone knows what one term means here. One term means if you have x to the power, for a given power of x, all the terms that are scattered here and there, if there's one term here, the other one here, then they should be clubbed together. That is considered one term. So this is considered just one term. If you have 6x here again, then this should be clubbed with these two, and that should be considered one term. So this still has only two terms. the number of terms will increase if you will add. Now, what should I add here to increase the number of terms? What can I add? I can't add something that is just x or just x. What should I add?
You can add a3x square. Sorry, x cube.
X to the power 4. You have to keep increasing the power.
If you look at increase number of terms,
Or any constant.
we need to add a constant. What all can we add? By we'll need, I mean what all can you add to increase the number of terms. So you can add a constant. You can add this a 3x cube. You can add a4 x to the power 4. You can add these terms. You can add 5 x to the power 5 and so on. Any of these terms you can add, right? And there's one more thing. Okay, let's just see this thing. One more point that we have here is, let's say you have a naught, or let's say you have 1 plus x square plus x cube plus, and this keeps going on. Do you understand what this means when you don't have anything written after it? What does this mean? This means that it keeps going on. That means you will have x to the power 100, then later you will have x to the power 1000, and this keeps going on. It never stops. So when you end something with just dot dot dot, that means this never stops. It keeps going on the same way, right? So if I have a dot at the end, that means you will have x to the power 1000, then x to the power 2000, 10,000, then in crores also you'll have, and this is never going to stop, right? Is this a polynomial?
Yes, ma'am, it is a polynomial.
Yes.
The one multiple. Yes.
Oh, yes.
Yes, ma'am.
But the that has to stop somewhere. Then only it's polynomial. Because
okay, let's see how many of you
n
think
should
that
be
it's a
defined at
polynomial.
least.
How many of you think it's a polynomial?
I think it's a polynomial.
Okay, so this thing, I think a lot of students think that this is a polynomial. It's not a polynomial. Because for this to be a polynomial, we already discussed this, that when you write a n x to the power n, your n is a fixed number. So it has to stop somewhere. That means you'll have to fix n. If your n is equal to 100,
That's what I
this should have
told. Like
stopped there.
n should be defined. Like it should be boundaried. Like then only it's
No.
polynomial.
Your polynomial is a function. So if you'll try this out for, let's say, if you'll put 2 here, x equals to 2, then this is a series here, and the sum is not, okay, for this one, it's the sum is defined. Let's not take this one, but there could be chances where if you will take the coefficients to be this, x, and then you'll take 2 here, then you'll take 3 here, then you'll take 100 here, and if it keeps going on like this, then this is not even defined as a function, because you can't find the value of this thing at 1. By that I mean that if you put 1 in this entire expression, then the value that you'll get will be 1 plus 1 plus 2 plus 3 plus 4 plus 5, and this sum is not defined. That means it's not defined in the sense it keeps increasing. This sum you can't even calculate, it never stops.
It's a divergent series, ma'am.
Yeah, I don't want to use that term because not everyone is familiar with divergent and convergent. So in simple words, you can't find the sum because it's too large. It keeps increasing. That's why that's not even a function. let alone a polynomial. So this is whenever you have terms not stopping, the terms have to stop in polynomials. So if you have something like this, a0 plus a1x, and it keeps going on, an x to the power n is not a polynomial. That's it. Then let's come to the second one, which is binomials. So in binomials, you can have x, you can have two terms. That means, so this is two-term polynomial. Your polynomial should only have two terms. That would mean you can have x and x squared, then x plus x cubed. This is also one example. That's what it is. Is it okay? You can also have x to the power 5 plus 1. That's also a binomial. And the third one is trinomial, which will have three terms. I think this is just waste of time. In a trinomial, instead of two terms, you have three terms. That's it. Can we move to the addition topic now?
Yes, ma'am.
Yes, ma'am.
Please.
Okay. Let's discuss addition of polynomials. We've already discussed when you write every polynomial can be written in this manner, right? Summation ai xi, where I varies from 0 to k, where k has to stop. K is a finite number, it has to stop. Now, if I write instead summation ai xi, I varying from 0 to infinity, then this becomes the series. This is called a series, and this becomes this. And this is not a polynomial. This thing is not a polynomial. So for addition of polynomials, if you have, let's say, a polynomial p1x, which is equals to a0 plus a1x plus a k x to the power k, and the other one p2x equals b0 plus b1x plus a bl x to the power l. If you have these two things, then how do you add them? So this is just term-wise addition, where you just add these terms. So add the constant terms. You will have a0 plus b0. Add the ones that have power 1. So this is a1 plus b1, x, these two. Then the one with the one with the variable x squared. So that will be a2 plus b2. And this keeps going on till. Now let's assume, because one of these numbers have to be greater, right? Either k is greater than L or L is greater than k, or they could be same as well. That's also possible. So without loss of generality, let's just assume that your k is greater than L. So if your k is greater than L, then you will have AL plus BL x to the power L, right? And then all the other ones will be just AL plus 1 x to the power L plus 1 plus so on till A k x to the power k, because there are no BLs after this. So let's take one example. Your example of this in simplified form can be written as, so this is the same as summation ai xi, I varying from 0 to k, right? And this can be written as summation bi xi, I varying from 0 to L. And what can this expression be written as? This can be written as summation ai plus bi x to the power I So why is no one correcting this thing? I wrote this by mistake. This should have been x to the power I, and this should have been ai x to the power I, right? These are powers, power 1, power k. This is it. I varying from 0 to. So if both of these are equal, k and l are equal, then you can write this as just k or l, because it doesn't matter, both of them are equal. But if they're not equal, if k is greater than l, then you should be writing this as l, and then summation ai x to the power I varying from, what should it vary from here?
L plus 1 to k.
To k. Is this clear to everyone, this expression? Let's take an example, then it will become clear. So let's take 3x to the power 5 plus 7x to the power 4 plus 2x plus 1. Take this one as p1x and take p2x as 3x to the power 3 plus 5x square plus x plus 2. Now, if this is it, how do you add these? And what does this thing mean? We start with I to the power 0, which is x to the power 0. So you add the coefficients of x to the power 0 in both. These are, so if you will expand this thing, this will be a naught plus b naught x to the power 0. And then it goes till
3 plus 0 whole into x to the power cube.
1 second. This goes till 3, a3, b3, x to the power 3. And then after 3, because the terms after x2, x to the power 4, x to the power 5, all of these are missing here, right? I'm trying to write this exactly as this one for you to understand what this expression means. So in this particular example, your L is 3 and your K is 5. So you do this sum till 3, till L, and then after this, you just take A4 x to the power 4 plus B4 plus A5 x to the power 5, right? So this is the same as summation AI xi x to the power I varying from L equals to 4. L plus 1, your L is 3 here, so it should be 4. L plus 1 should be 4, 4 to 5. And this is the same as summation AI x to the power I varying from 0 to 3, which is L, right? I hope you can see you can compare this with this expression. And now you can understand why this expression is true. Let's try to solve this. This is adding the coefficients of x to the power 0 gives you 3. So p1x plus p2x should be, add the coefficients of x to the power 0. You'll have 3 x to the power 0. Then the coefficients of x, which is 1 and 2. So add them, you'll have 3x. Then the coefficients of x squared. We'll go step by step. So we have constant term, then x squared. So we have the coefficient of x square 5 here, and the coefficient of x square here is, what's the coefficient of x square here?
0.
Right, it's 0 here. So it should just be 5. 5x squared, which is 5 plus 0. And then let's move to x cube. We don't have a term of x cube here. That means it will be 3 plus 0 x cube. And for x to the power 4, there is no term of x to the power 4 here. So we can just take this one, 7x to the power 4 and 3x to the power 5, because there are no terms of the exponent 4 and 5 here. So this is 7x to the power 4 and 3x to the power 5. This will be the sum. Is this okay, or should I do the usual way where you write this entire P1x as x to the power 5 plus 7x to the power 4, then all of it, and then the missing terms as 0 plus 0 x cubed plus 0 plus 5x square plus x plus 2 x to the power 0. This is written in the general form. The a naught plus a1x plus so on an x to the power n form, right? And then you write P2 in the same form and add that. This is 3, 5, 1, 2. It's 3x cubed plus 5x square. And you should be writing 3x cubed under 3x x cubed position, right? So this will be 3x cubed plus 5x square plus I've written this thing wrong, right? This is 7x to the power 4, and then you don't have the this is also 0. This is 0, this is 2, and this is 1, I guess, for P1. And similarly, you do this thing for this. So you'll have x plus 2x to the power 0, and then add them side by side. So these are just 0, 0, right? Then you can add them the usual addition way. Is that okay? Can we move to subtraction now?
Ma'am, actually, I understood the
Subtraction is
concept. But can you just clarify the thing that you wrote up on the screen above?
this one.
This one, the went down. No. This
This one
A
you're
not.
talking about, right?
No.
Or
This
this one?
one. Yeah.
Okay, this is just if you're going to add these two polynomials, then how do you add them? Let's say this is a0, this is a1, this is a2, this is a3. Or we should be writing it as those, right? This is a1. If you compare it to a0, if we see this as a0 plus a1x plus so on till a5x to the power 5, then this is a0, this is a1, this is a4, and this is a5, right? And if we'll consider this as b0, this expression, this one as b0 plus b1x plus b3x cubed, then this should be b3, this should be b2, this should be 1 should be b1, and this should be b0, right? So if I were to consider this thing, now comparing, you understood this part. Did you understand this one?
Yes, ma'am.
So this is
Yes, ma'am.
clear to you, right? This one, the one that I've written here, is just the expansion of this one. I was trying to make things clear that if L, because we have taken k greater than L, so I have taken k to be 5 here. The degree of this one I've taken to be 5, and this to be k, and this one as L. For you to draw comparison from here, that's it. For you people to see why this is just L. We said that this should be L plus 1 to k, and this should be from 0 to L. That's what we've done here. A naught, B naught, X. The coefficient of X naught, coefficient of X, coefficient of X cube, then coefficient of X to the power 4, but we don't have the coefficient of X to the power 4 here. That's why we've simply written the coefficient of X to the power 4 from the above expression. This you can view as this 0 plus 8 to the 0 plus 8 to the power 5.
Okay. Thank you.
So I said this expression ai x to the power I is the same as this one. Sorry, I should have written ai plus bi x to the power I. This expression is the same as this one, and this other expression is the same as this one, where we have bi is missing.
Okay.
Right? That's. Can we move to subtraction?
Yes, ma'am.
It's very same to addition. So let's say you have two polynomials. Your one polynomial is minus 3x squared plus 2x minus 2. And the other one, let's say, the P2x is x cubed plus 2x squared plus 8x. Now, if you subtract them, let's say you want to find P1x, or let's say this P2x minus P1x. And how do you find it? You first write P2x here, simply just this, or you can do it without doing this stuff as well. You can subtract the coefficients of x to the power i's of this one. Okay. Write this thing here first. You'll have x cubed plus 2x squared plus 8x. And actually write this as, because I'm missing terms too, so write this as 0x, no actually it's 8x, right? 8x plus 0 times x to the power 0. So now this is written in the general polynomial form of the form that we have discussed a lot of times, a0 plus a1x, that form. It's written in that exact form. And then this other polynomial is, so write this term, the square term under the square term, the cube term under the cube term. Write these things as this. So you'll have, we don't have a cube term here, right? That means it's 0, because p1x does not have a cube term. So you can write it as 0x cube minus, so subtracting this entire thing. And then we have an x square term, which is minus 3x squared. So you can write this as minus 3x squared. Then the x term is 2. And this term is, the constant term is minus 2, right? And then these signs get changed. This becomes minus, this becomes plus, minus, and plus, right? So this will give you just x cubed. This will give you 2x squared plus 3x squared. So this will be 5x squared. This will give you 8x minus, you have to consider this sign, right? So this becomes 6x. And this gives you 0, x to the power 0 plus 2x to the power 0. This becomes this. Is this okay? Or alternatively, what you can do is you can subtract the corresponding terms. So subtract the cube term of this from the cube term of this. But here your cube term is 0. That means you'll have to do x cube minus 0x cube. It's exactly the same that we've done here. Besides, here we've done it in a proper manner, and here we are just doing it by looking at the expression. Is that okay? Can we move to the multiplication topic if this one's fine? Is this one, if this one's clear to all, can we move to the next multiplication of polynomials?
Yes, ma'am. Yes, ma'am.
Okay. So for multiplication of polynomials, it's basically, let's say one of your polynomial is summation ai x to the power I, and the other polynomial is summation bi x to the power I. So let's say this is p1x and this is p2x. We have an expression for the multiplication. which is not needed. If you have to, let's do an example on multiplication, and then we can discuss the expression. Let's say you have 2x squared plus x plus 1, and the other polynomial is x squared plus 2x plus 3. Now, how do you multiply these two polynomials? The multiplication does not happen like addition. In addition, you used to add only the corresponding terms, the square term with the square term. That doesn't happen in multiplication, right? Multiplication, you multiply, you take this one and multiply it with all the terms. That means 2x squared multiplied with x squared, the first term here, then 2x squared multiplied with 2x, then 2x squared multiplied with 3. And then you take up the next term here, which is x. So x multiplied with the first term here, x squared, then x multiplied with 2x, then x multiplied with 3. And then you take up the third one, which is 1 multiplied with x squared, then 1 multiplied with 2x, which is simply 2x, and then 1 multiplied with 3. That's how you multiply. This simply means that you have to multiply each one of these with the other ones on the other side. Is that okay? That's how multiplication works in polynomials. Now, for the general expression, let's say you have one polynomial as ai x to the power I, and the other one as I varying from 1 to, and the other one is summation bi x to the power I varying from 0 to, let's say, n. So what do you think is going to be the highest power here? The highest power here is n. Here we have n. What is going to be the highest power of this multiplication?
M plus n.
M plus n. Right? So you will, because, okay, let's see the expression first. So the expression becomes aj bk x to the power j plus k summation, and then we have a summation again. So, or what we do here is basically we add, if you look at this, simply means that what you're doing is to take x, let's take j here, because taking I is a bit of a confusion. So what you do here is you take x to the power I, let's say you have x to the power 1. If you have to find the coefficient of x to the power 1, then you see at the split of x to the power 1. So 1 is split into either this one could be 1, the other one could be 0, or the other one could be 0, or this one could be 0. We're talking about the powers of x right now. That means you have to multiply the power of x, the coefficient of x from here, and the constant from here. What I mean is this thing. If you have 2x squared plus x plus 2, and you have x plus 1 here. Now, if you have to find the coefficient of x in the multiplication, or if you, let's start with the highest power or the least power. Least power is going to be 0, right? So if you have to find the coefficient of x naught, then it could be, how do you get x to the power 0? And this is only possible when you multiply x to the power 0 with x to the power 0, right? That means you'll only be adding, you'll only be multiplying the coefficients of these, the constant ones. So you get 2. You don't have to check anywhere else. Then for x to the power 1, your 1 is either you're multiplying x term from here and constant term from here, right? Like in this one, x into 1. That's when you get the total as x to the power 1. Or you're multiplying x from here and constant from here, which is 2, right? Because 1 can be split into 1 degree, 0 degree. So when 1 degree gets multiplied with 0 degree, or 0 degree gets multiplied with 1 degree, you get 1 degree, right? So that's why this is 1 degree, this is 0 degree. This is 1 degree, this is 0 degree. So this becomes so x to the power 1 will become a naught b1 b naught a1. Is this okay? Or in this
Yes, ma'am.
particular expression, it's going to be 2 plus 1. So it's going to be 3 here. Then you do the same with x square. So if you do this thing for x square you can get if you have 2 0 or 0 2 or 1 1, right? So that means if you take x to the power 2 and x to the power 2 from here, x to the power 0 from here, which is this. If you multiply this one, x to the power 0 from here, and this one, x to the power 2 from here, you will get x to the power 2 as resultant, right? So 1 is 2. And the other one that you add is 0 from here and 2 from here, but you don't have a 2 degree here, so you can skip this one. And the other one is 1 1 from each, so which is 1 degree from here, 1 degree from here. So this is 1 and 1, so you get 1 here. This becomes 3 again. So this becomes 3x squared. And then finally, then for x we've already done, right? And then finally for x square, no, then we have x cubed. So for x square, you'll have to add x square is done, so this is x cubed. For x cube, you'll have to split cube into, so this will be either 1 or 2. It can be 0 and 3 as well. 0, 3, 3, 0. Then you'll have 1, 2, 2, 1. Then you'll have 3 is done, right? Those are the only possibilities, right? These are the only possibilities. So you have 0 term here and 3 term here, but that's not, we don't have a term with 3 exponent, so we can skip that. Then 3 term here, 0 here, that's also not possible. Then 2 here and 1 here, this is possible. 2, degree 2 term, this one, degree 1 term, this one, so this will be 2. And then you have degree 1 term and degree 2 term, that's also not possible, so this is just going to be 2. So the formula for this becomes because we were splitting the exponent of x, right? So if you have 3, you split it, you check how can you split it. That means the expression for summation ai x to the power I taken product with bi or bj x to the power j should be equal to so if you try to find the exponent of x to the coefficient of x to the power 0 in this product, what would it be? It will just be a naught b naught, right?
B naught.
That's the only possibility. Then if you try to find for x to the power 1, you will have a naught b1 plus b naught a1, right? Then for x square, you will have a naught b2, b naught a2, a1 b1, right? It keeps going on like this till you reach. So if this is till m and this is till n, so till you reach xn plus n, there'll be sums. So if you have x to the power n plus n here, then the a naught or ai bj, it should be ai bj's and taken sum of, right? Summation ai bj such that I plus j is, or you should have, this sum is equals to m plus n. So this is the condition where your I plus j should be equals to m plus n. because we want this sum to be equal to the exponent, right? And then we take the sum again. So this becomes summation ai bj x to the power m plus n, or you should say x to the power l, where your I plus j should be equals to l, and you should have l varying from 0 to, what's the degree? M plus n, right? This. Is this okay? Do we have a confusion here? You guys don't actually need to know this expression, but it was for you to see how things are done. How we've written this expression is basically instead of m plus n, because this thing is varying, right? Here it's particular. Is it clear till this part? How we've done things here? You have
I
a
think
doubt?
the no, ma'am. It's just that it's always easier to see the polynomial without having this general form. But once these expressions come in question, it becomes a little too much to analyze that.
That's why I wanted to discuss this thing so that
Yes,
it
ma'am.
doesn't scare you in the activity questions and all.
Yes, yes,
Because you
yes,
will
yes,
see
ma'am.
this form there.
Mm-hmm.
So this is how do you, this is till this part it's clear, right? We're not doing anything, we're just taking ai. If you have to find the, what we've done here is, if you have to find the coefficient of x to the power 10, then what you should do is to split 10 into parts. What can you split it into? You can only split it into two parts. You can take it as 0 10, 10 0, then 1 9, 9 1, and there are a lot others too. So how do you write it? X to the power 0. So you write it as a naught b10 plus b naught a10 plus a1 b9 plus b a9 b1, right? And it keeps going on because it's a long thing. This is not done yet. Then you'll have 8 2 2 8, right? It keeps going on. There's a long list. So this is the coefficient that you get when you multiply. This expression is coefficient of x to the power 10 in summation ai x to the power I taken product with summation bj x to the power j, right? So if you have to find the coefficient of x to the power 10, just find the terms a naught b10 such that the sum of these becomes 10. Sum of these should be 10. 1 and 9 is 10. Then later you'll have a8 b2 b8 a2, right? That's what we've done here simply. So this expression can be simplified into this entire thing as, let's take L to be variable, and you'll have L varying from 1 to m plus n, right? Because the power, the highest, you guys only told me that the highest power that you can have is m plus n, right? In this product. The highest power could be m plus n. Then you just have to write the coefficients of x to the power L. So what are the coefficients? For x to the power 10, the coefficient is this, right? Where the sum of these indices become 10. So for x to the power L, what should be the coefficients? You will take A. If you will take A1 here, and what should I take as B? The index of B. It should be L minus 1, right? So if you take L minus 1, your sum will be 1 plus L minus 1, and this will be L. Right? You can simply write this expression as AI Bj, where I plus j is L. That means I want the sum of these two to be L. This is the condition here, I plus j equals to L. When you write something under the summation, that means this summation has to follow this condition. Or you can also write this as L varying from 1 to m plus n. And instead of writing two things, I and j, you can simply write AI and B L minus I. As we discussed, if you have A1, then here you should have B L minus 1, right? If you have A2, then you should have B L minus 2. Summation, your I varying from 0, because it starts with A0 BL plus A1 BL minus 1 plus A2 BL minus 2. We just need the sum to be L. Sum of 0 and L is L. Sum of 1 and L minus 1 is L. Sum of 2 and L minus 2 is L. That's why we're taking this expression. And this should start with 0, right? Because everywhere it's starting from A0 B10, starting from A0 B0, A0 B1, A0 B2. So it should start with A0, right? So I starting from 0, and where should it end? So if you keep going on like this, and you have the coefficients of this going till n, right? So you can have an, and here you'll have bl minus n. Now if it's not there, it depends on the coefficients too, then you can simply take it to be 1, right? This should be taken till n. Or actually, your L not n. So if you take 10 here, it will go till you can take A10 and B0, right? So this is going till 10. If you're taking this here, so it should go till n. Is this okay? Are these expressions clear to all? If at all you see confusion in these expressions, you don't have to learn them. You can just check by doing what I have done, because I also didn't remember it. I've tested it and then I've written it accordingly as to what I'm getting while multiplying. So you can do that if it's confusing to you. Can we move to division of polynomials now?
Yes, ma'am.
Okay.
Yes, ma'am.
So for you to, let's say you have a polynomial px and you're dividing by, let's say you're dividing it by px. And if you're dividing a polynomial px by px, then this is, okay, let's try to divide first. Let's take example first and then we'll discuss the theory part. So let's say you have your one polynomial that is getting divided is this. and you're dividing it by 3x equals x square plus x plus 1. So this is because this is getting divided, so this is called dividend, and this is called divisor. Let's try to divide this the usual way. So here you will write x to the power 4 plus 2x square plus, let's write the cube term too, 0x cubed plus 2x square plus 3x plus 2. And then here you have x square plus x plus 1.
Also, we can find the factor of dx and then it will satisfy this equation, and then the whatever remainder is there, remaining term, that would be remainder.
What?
If say we rather than x square, if we can find the factor of this divisor, then in that case we can put that term x is equal to say whatever value it comes, we can put that value in px to get the remainder. If at all we get the
That's only
factor
for
of
linear factors. It doesn't work for square. The quadratic factors, it doesn't work. It's only for the thing that you're saying to get remainder. Remainder theorem, we'll also discuss that. Let's first do the basics of division. Then we'll come to remainder theorem and factor theorem and all. Let's do the basic division part first. Let's quickly go through this. So I should first take x square, so that x square and x square becomes x to the power 4. Look at the highest power and what you need to multiply to get that highest power. Now let's say you add 3 here, then you will have to multiply it with 3x square. So you will get 3x square into x square equals 3x to the power 4. But since you only have x to the power 4 here, you can divide it. You can use x square. So this will be x to the power 4. Then this will be x cubed and x square. Change the signs here. This get cancelled, you get 0 here. X to the power 4 minus, these are the signs that you need to consider. Forget these ones. Change the signs of these. This is positive here, change it to negative. Positive here, change it to negative. If you had a negative here, you will need to change it to positive. Just change the signs here. And now these will be the applicable signs. That means add this to minus of x to the power 4. Add this to minus of x cube. Add this to plus of x. But in this case, you have plus here. You have this. So x to the power 4 added to minus x to the power 4 is just 0. Then you will have 0x cube minus x cube. So this is minus x cube. Then here you will have 2x squared, and you have to consider this sign minus x. So this becomes 2 minus 1, or you can just say 2x squared minus x squared. And the rest of these, they remain the same, right? Because you will have 0, 0 here, and it doesn't make any difference. So this will just be 3x plus 2. So it results in 2x squared minus x squared, which is just x squared. This. Then next up, what should I multiply this thing with? So I need
Minus
the
x.
highest is the highest degree is this. So you should multiply it with, or to get negative, because you have positive here. So to get overall negative, you should multiply it with a negative thing. And that negative thing should be x, because x square is already here. X when multiplied with x square gives you x cube. And negative sign and positive sign ensure that the coming term results in negative x square. So if you do this, multiply this with this, you'll get minus x cube. And multiply this thing with this, you'll get minus x square. Multiply this thing with this, you'll get minus x. And change the signs here. These are the applicable signs now. So minus x cube plus x cube gives you 0. plus x square gives you 2x square, plus 3x plus x gives you 4x, and the 2 remains because you have 0 here. So this becomes, you don't have to do this because, so you can just simply take this thing down. You don't have to write a 0 here. Instead of writing a 0 unnecessarily, you can just take this thing down directly. But if you had, instead of 2 here, if you had 2 here, plus 2, then you'll need to change the sign here first. And then what you'll write down here will be minus 2, not plus 2. If you had minus 2 here and 0 here instead, then you will be writing minus 2 here. So now we had plus 2 here, right? This will be plus 2. Then finally, because you have 2x square here, and here you have just x, you should multiply it with 2, right? So 2x square gives you 2x square plus 2x plus 2, right? This will give you negative, negative, and negative, and this is going to be 0. This is going to be 2x, and this is going to be 0. So this should be left then. So this is very similar to what you do in your usual division, right? When you divide something and at the end you get a remainder, then you no longer, when you're no longer able to divide, then you get the remainder. Now you have 2x here. Let me just, I've not made any mistake, right? X to the power 4, x cubed, and then x squared. This should be minus x minus x. Okay, so this is what you're going to get. So that means now if you write these things, when you divide this, let's say you're dividing 27 with 2, and what you do is you first you write 13 here, then you'll get 26, and you'll get one remainder. So you write 27 as 2 times 13, and then 1, right? So the same we do here. Let's call this thing, this is the remainder, right? And why is it remainder? Because the degree of this expression is 1. And here you have, now here your degree is 2. Even if you keep a constant here, the minimum degree you will get is square. If you will keep a constant. So because this degree is less than the degree of this, when do you stop this algorithm? This is the division algorithm, and you stop when degree becomes less than that of divisor, right? So if your degree becomes less than the degree of divisor, then you stop this algorithm here. Because this degree is 1, this degree is 2. 1 is less than 2, that's why you stop here, and this is called the remainder then. So this is remainder, and this is then called the quotient, right? So this is qx, this is rx, and this we had taken as tx and tx, right? So that means your px is equals to, in a similar manner, you can write this thing here, px times qx plus rx, right? This is your qx, this is your tx. This entire expression is px, right? So px is basically this multiplied with this thing, and then you add the remainder too. this expression. Now two things happen. The important part is you can write if you have a polynomial and you have another polynomial and you're dividing this polynomial with, provided the degree, first condition is that your degree, otherwise you'll always have 0 here, right? If your degree is of tx is greater than the degree of tx, then what happens? What will happen if you have this degree greater than the degree of this? That means you can't start with the division, right? That means your remainder is tx. So in division algorithm, the first thing is that your degree of Rx remainder that we discussed. So either your degree of either your remainder is 0 or your degree of remainder should be less than the degree of tx, right? This is what we discussed, that the degree of this thing should be less than the degree of this tx. Now there could be cases when your Rx is 0. Why do we not include this Rx equals to 0 case here? Why are we making a separate? They're saying that if you are using this algorithm, if you'll divide px by tx, then your remainder is either 0 or its degree is less than the degree of this. Why can't we include this case here? Does anyone want to answer why this case is mentioned separately, this one? Okay, if your remainder is 0, and you can't find the degree because degree of 0 is not defined, right? That's why this case has to be mentioned separately, because if your remainder is 0, then degree of 0 is not defined. So you can't say the degree of 0 is less than equals to degree of tx. In fact, it should be strictly less than this. The degree of remainder should be strictly less than tx, because if you have same degree, if you have square here and square here, then you can divide it further, right? That won't be the remainder. So the degree should be
Yes.
strictly less than. This means not equals to. Shouldn't be equal. And we're taking this case separately because if your remainder is 0, then degree is not defined. That's why we say either the degree of Rx is less than, strictly less than tx, degree of tx, or your remainder is 0.
Go to the example as you were showing.
This one?
Yes, you were showing here. Degree here 2x is degree 1.
Yeah.
And px, the remainder 2x,
Yes.
the remainder 2x is degree 1.
Yes.
Okay. Acha, you mean to say the qx, like the, okay, the px, okay. Yes, if there is equal to also, then it's a possibility to divide it further.
Yeah, that's why we don't include equals to it's not allowed here. So if everything here is clear, then maybe we can do one question on this degree thing to cover everything. Let's do not this one. Okay, just 1 second. I wanted to have another example here. We'll come to this one, but let's do other thing first. This other thing is, let's say you have tx, and then you're dividing it with another polynomial qx. And let's say hx is the quotient and rx is the remainder. So what can be the maximum? Okay, in this particular one, so we've already discussed a cap on the degree of Rx, right? What's the maximum possible degree of Rx in terms of other degrees?
Lesser than PX.
Lesser than Px, but we have to discuss this in lesser than Qx or Px or whatever you're saying, but we have to discuss it in terms of number, not what it's less than. I'm asking what could be the maximum possible degree. Let's say other degrees are given to you. The degree of this is given to you. Then can you say something in terms of equal to? Maximum possible degree equal to. We don't want less than and all here. What's the maximum possible degree? So Qx is the divisor, right? So it's less than the degree of, if you're saying that the degree of Rx is less than the degree of, strictly less than the degree of Qx. Let's say I say that that there's a number m and it's strictly less than 10. Then what's the maximum possible value for m?
9.
9.
The maximum possible value for is 9, right? So here the maximum possible. Now can you tell what should be the degree of the maximum possible degree of Rx?
Px minus 1. Degree of Px minus 1.
Okay, we have Px divided by Qx. So this is what you're dividing. This is here, and you have your Qx here. You're dividing by this. It should be degree of Qx minus 1,
minus
right?
1.
Because you're dividing by
Yeah.
what you're dividing by is what matters. So this should be it. Now let's say your degree of Px is strictly less than the degree of Qx. So what we're doing here is we have Px here, dividing it by Qx, and then we have an Hx here and Rx here. And this says that your degree of Px, let's say, is less than Qx. Then what should be your Hx? Can we say something about Hx? Yeah. If you have, let's say you have, yes, if you have x square here and you're dividing it with x cube, what happens?
We can't divide it.
Then it's divisible.
So that if you were to write it as in that manner, it will be in that manner. By that I mean Px is equals to Hx times Qx plus Rx.
Can't divide it. Or if we divide it, then 1 by x.
You can just simply take Hx to be 0, right? And then if you take this thing to be 0, then your Px would be the same as just the remainder. You wouldn't your Px would become Rx only because you have taken Hx to be 0. So you can say your degree of Px will be the same as degree of Rx. Right? Actually, your Px and Rx would be the same in this case. If you will try this out.
Yeah.
So, and next up, I forgot to mention one very important thing that we were supposed to discuss, which is factor theorem and remainder and all. So let's say you have a polynomial, and I say, so let's say x minus a is a factor of px. Then I can write px as, because x minus a is a factor, right? So I can write this means x minus a divides px. That means I can write this as px equals x minus a multiplied with some qx, right? Where this will be the quotient when you divide px with x minus a. Now if I substitute a here, you have let's say you have x minus, this should be the thing here, right? If you have x minus a, or if you're, let's say you're dividing x minus a, divide px by x minus a. So if you'll divide px by x minus a, then this is the expression that you should be getting, right? This is the dividend, this is the divisor, then quotient and the remainder. Now if I substitute a in place of x, I'll get pa is equals to a minus a qa plus ra, right? And let's check this thing here as well. When we apply this division algorithm, we know that the degree of Rx should be less than degree of the divisor, right? And the divisor is x minus a. That means degree of Rx should be less than degree of x minus a, strictly less than. What's the degree of x minus a?
Reiterate this part.
If you will divide px by x minus a, then you will get this expression, right? Let's say you divide px by x minus a, then by division algorithm, you should get px equals to x minus a. This is the divisor, then this is the quotient, and this is the remainder, right?
Px is equal to Ra. Pa is equal to Ra. That we will get.
Okay, we'll come to this one later. Let's have a look at the degree of Rx. And we know that when we use division algorithm, according to this is called the division algorithm. So your degree of remainder should be less than the degree of your divisor, right?
Yeah.
So your divisor is x minus a here. That means your degree of remainder should be less than degree of x minus a. What's the degree of x minus a?
1.
1. That means your now what does this mean? What should be the degree of, can we say anything about degree of Rx?
Yeah.
Zero.
What is it? What can we say about the degree of Rx?
0.
0. And is there any other possibility? We discussed one more case where we said either your degree is 0 or your Rx is 0, right? That's also a possibility, right? If your remainder is 0, then we can't say that we can't even talk about degree of Rx, right? That means either not and, either this happens or your remainder is 0. Is this part clear to everyone?
Yeah.
Okay. Now this means that this thing is a constant, right? This implies that your remainder for sure is a constant. It's either 0 or some other constant, right?
Yeah.
That means you can simply replace this thing with x minus a qx and just r, where r is a constant. Now, if you substitute a here, let's say your function is, let's say you have this function. Just 1 second. Let's say your function is 2. Then what is the value of f5? If the function is constant function 2, then what should be the value of f5? The function's
2.
value when we keep x equals to 5. It should be 2, right?
Yeah.
So that means if I substitute a in RA, and your R is a constant function, that means RA should just be A, right? RA should just be R, right? Because it's a constant thing. This should mean that your PA should be equal to 0 times QA plus R. Is this fine to everyone?
Yeah.
This means your PA should be equal to R. Now, what does this mean? Our conclusion is if PA is the remainder, then Px is divided by x minus A. That means if you have x minus 2 and you're dividing x square plus 2 by this polynomial, then your remainder, what should be your remainder? If this is your Px, and this is this, what did we take the other? This is what you're dividing with. Then what should be the remainder here?
0.
0. How do we find the remainder? First, we take 2 from here, because if we have x minus A dividing Px, this implies remainder is PA, right? This means if x minus 2 is dividing x square plus 2, then the remainder should be A is 2 here. That means it should be, you substitute 2 here. So you'll get 2 square plus 2 with 6, right? So the remainder should be 6. Is this okay?
How did you calculate? Can you explain this again directly before?
Yeah.
Without long circle.
What we're doing here is we have this conclusion that if you divide Px by x minus A, and this only works for linear factor of this form, x minus A form. If you divide Px by x minus A, then the remainder should be PA. Right? That
Okay.
means if you're dividing x square plus 2 by x minus 2, now compare this situation to this one. That means your remainder should be P of 2, right? And P of 2 is this. Correct? Is this fine?
P of 2, I didn't get it.
If you have you divide px, if this is the thing, if you have px here, and you're dividing it by x minus a, then your remainder here, what you get at the end is pa, right? Now in this case, you have x square plus 2. You're dividing it with x minus 2. Then the remainder should be, you
Yeah.
substitute 2 in this,
P of
right?
2.
So it should
Yeah.
be 2 square plus 2, right? So this should be the remainder. That's it. That's what we've done here. P of 2 equals 2 square plus 2 equals 6. Now let's say you have, let's take it further, and let's say you have x minus a, and x minus a, let's say x minus a divides, so we can say x minus a is a factor of, let's say x minus a is a factor of px. Now if x minus a is a factor of px, that means x minus a divides px, right? That means px is equals to x minus a times some quotient, and your remainder should be 0, right?
Yeah. Yeah.
Now what should this mean? This should mean, and we know that your remainder is given by p of a, right? That means your pa should be 0, right?
Yeah.
So in conclusion, what you have is x minus a is a factor of px. This is if and only. If and only if means if this happens, then this will happen. If this happens, then this will happen. If x minus a is a factor of px, that means your pa should be 0. And if pa is 0, then x minus a is a factor of px. That means let's say you have x square minus 4. Now, if I'll do p of 2, I'll get 0, right?
Yeah.
Now this should mean that your x minus 2 is a factor.
0.
Similarly, your p of minus 2 is also 0. So x minus 2 and x plus 2 both are factors.
Okay.
Is this fine?
Yeah.
That's it.
Mm.
So
We are factoring the middle part, right?
what?
Nothing.
It's one question on this. Let's say you have this polynomial and it leaves a remainder x minus 2. So this question says, the question is visible to everyone, right?
Yeah.
This is the question. It says, this is the polynomial, and these are two polynomials. Let's call this one px, p1x, or this one p2x. So it says that they leave the same remainder and divide by x minus 2. So what's the remainder? What's the remainder when
X is equal to 2.
p1x is divided by, what should be the remainder when we divide this by x minus 2? What should be the remainder?
Put X is equal to 2, then we get that remainder.
So it should be p12, right? Remainder when p1x is divided by x minus 2 is p12. Similarly, remainder when p2x is divided by x minus 2 is p22, right? So you will substitute 2 in both of these polynomials. One is x cubed plus ax squared plus 5x plus 7. And the other polynomial is x cubed
Plus 2x squared plus 3x plus 2. 2a.
These are the two polynomials, right? So to find the remainder when this is divided by x minus 2, you need to substitute. So your remainder will be p1, 2, which is equals to 2 cube 8 plus 4a plus 10 plus 7. So it will be 17 and 8 is 25. This will be 4a plus 25. And then you will substitute 2 here, where the remainder will be p22. This is p2. So your remainder will be 2 times 4 with 8 plus 6
8
plus
25.
2a. It's 14 plus 2a, right?
X cube.
Yeah.
So, and now this is given to you in the question. The question says that it leaves the same remainder. That means both the remainders should be same. That means 4a plus 25 should be equal to 14 plus 2a.
14 plus 12.
So this gives you 2a.
8 plus
14, this is minus 11. So this should be a equals to minus 11 by 2. Is this okay?
Ma'am,
Maybe you are not
ma'am, X cube. X
Have you made a
cube.
mistake?
X cube की value.
Okay. This is, thank you.
Plus
We left x cube. So it should be 8 here, right?
4.
So this will be
16.
22.
22.
22 here, and then this will just be minus 3, right?
3 by minus 3 by 2.
Yeah, minus 3 by 2.
Right.
That means your a should be minus 3 by 2. Is this okay? Now, I think it's already half hour past the usual time. If does anyone have any doubt?
When will this lecture get recorded in uploaded in YouTube?
Yeah, it's live streaming on YouTube.
It's going live. So it's already there.
Can you share the link?
On
Can
calendar.
someone just there's a YouTube channel for it. Can someone paste the link? Because I'll have to look for it. Thank you.
I have shared the link.
There's a YouTube channel for it. Can someone paste the link? Because I'll have to look for it. What? I can't hear you clearly.
I have shared the link.
Should I stop sharing my screen if we don't have any doubts? Or if there are any doubts, we can take them up tomorrow. Is that okay? So I'll end the session here then. See you guys tomorrow.
Okay, good night, ma'am.
Okay, ma'am. Thank you.